See how long it will let me record for. Okay, so we are doing number 2 from worksheet number 3. So we have log base 2 of the square root of 8. All right, remember, when you have a log, it's log base, our argument is our answer, equals exponent. So this doesn't equal anything, so I'm going to put equals x. So now what we do is we're going to change it back into exponential. When we change it back into exponential, this is saying 2 to the x power is equal to, how do I write the square root of 8 as an exponent? 8 to the half power. I always write radicals as exponents when we're doing logs. Anybody confused with how I went from our original problem to our exponential?
This sounds wrong, very uncomfortable.
Okay. Now we have 2 to some power is equal to 8 raised to the half. What do you think I'm going to tell you to do with that 8?
Make it the same as 2 like the base.
Good, make it as a base of 2. So 2 to the x is equal to 2 to what power gives us 8? 3. So we have 2 to the third raised to the half.
Why is it raised to the half?
Because a square root is a half as an exponent. So I always change radicals into exponents. So now when we have a power to a power, what do? We multiply. So we have 2 raised to the 3/2 power. Because they both have the same base, can I just say x equals 3/2? That's it. Okay, number 4. For number 4, do we want to go through all the shortcuts? Well, before we do number 4, let's go through all the shortcuts. I have to remember the shortcuts to write them out. So if I have log base b of b to the t, what did that simplify down to? T, you got it. We had to memorize these, yes. I'm trying to remember all of them. What else was there? There was... Well, I know the shortcuts, but I don't know. Like, when I see it, I'm like, oh, this is a shortcut. Let's just do it. But I don't remember the actual... What was the other one? It was... Oh, yes, log... Oh, no. It's when it's b raised to the log base b of t. That was the other one. Yeah, don't worry. It's t. So no, now your log is in your exponent. Oh. Guys, just relax. Yeah. And don't worry. You'll get it when we could do one. So what I'm saying is if this is 2 raised to the log base 2 of 8 equals 8. That's what the shortcut is. This one was saying if I have log base 2 of 2 to the third, this is 3.
Yeah, that's the one I was talking about. Oh, wait.
These are just examples of what the rule is. Yeah. And I think the other rule was just doing it with the ln. So if I have the ln, what was it?
Natural log.
Yep. ln of e to the t is equal to t. Same rule. It's really just the same exact rule. I'm just writing ln instead of log base e. And the same thing here, if I have e raised to the ln of t, that equals t. I think that was everything. Hope so. Okay. If there's more, I'll notice when we do a problem. All right. So, number 4 from the worksheet. ln of e to the second power. Exactly. Isn't this a shortcut? Yes, this is just 2. All right, number 6 from the worksheet. Log base 9 of the 5th root of 27. Before I do anything, I don't like to deal with radicals. I like to deal with exponential. So I'm going to change the 5th root of 27 into an exponent. So this is log base 9. How do I write the 5th root of 27 as an exponent? 27 raised, Nico? To the 1/5. Now we're going to change the whole log into exponential, and that goes back to what I wrote down in the beginning. Remember, log base answer equals exponent. So using that, can you change this back into exponential for me? 9 to what? Good. 9 to the x is equal to 27 raised to the 1/5. We're going to need to solve for x, but I want them to have the same base so I could set their exponents equal. Nico?
Wait, why is it x?
Why is it x? Because remember, it's log base answer equals exponent, but is there any equal sign here?
No.
So that's the unknown, so equals x. So I'm going to change these both, not into a base of 9, I'm going to change them both into a base of what? 3. So we're going to have 3 to the second raised to the x is equal to 3 to the third raised to the 1/5. Everybody okay with how I manipulated these? All right, so now we have 3 to the 2x is equal to 3 to the 3/5. Because they have the same base, now I can set their exponents equal. So now I have 2x is equal to 3/5. I need to get x by itself. So I can divide by 2, but dividing by 2 is the same as multiplying by what? 1/2. That's what I'm going to do. I'm going to multiply by 1/2 here and multiply by 1/2 here. That way, these cancel, and I end up with x is equal to 3 times 1 is 3, 5 times 2 is 10. All right, can I go on to number 8? So we need to evaluate this, which means I need to get it just to be one number. That's what it means to evaluate, find out what number it is. But because I have both log base 5 and there's subtraction between them, does anybody remember what I can condense it into? Erin? Division. So what you do here is you're going to pull out just one log base 5 and then you're going to divide their arguments. So 75 divided by 3. And what's 75 divided by 3? 25. So now I have log base 5 of 25. You have to now solve it, exactly. So now that I got it down to 1 log, now we solve it. How do I solve this? What do I write down? 5x equals 25. Remember, it's log base answer equals exponent. But do we have an exponent? No, so that's why we put equals x. So 5 to the x equals 25. We could do this. We don't need to make the same base. What does x have to be? 2.
Are we going to have one where we have an exponent?
Yeah, there's all different versions of things I could ask for. All right, are we ready for the next one? This was number 8? Okay, number 9.
10.
Oh, number 10, sorry. Because they both have the same log base 6, I can condense this down into 1 log. But before I do that, this 2 in front, I can put it back as what? As an exponent on the square root of 54. So this is log base 6 of the square root of 54 squared. But good. What happens when you square a radical square root? Doesn't that just cancel out the square root? So this just becomes log base 6 of 54 minus log base 6 of 9. How do I condense this? It's log subtraction with the same base, so I could pull out just 1 log 6 and do what with the arguments? Divide them. Oh, this was another rule. Well, you don't need to know all the rules. You could do it the long way. So I'm not even going to tell you the shortcut here. All right, let's change this into exponential. Janine, tell me, how would I change this into exponential? So remember, it's log. This is really the only thing you have to memorize. It's log base answer equals exponent. Is it equal to anything here?
No.
So we have to put equals x. So now change this back into exponential. Uh-huh. Equals 6 to the exponent of 1, because there's nothing there, right? So what does this mean? X has to equal 1. As long as you can change it back into exponential, you really do not need to memorize any of the shortcuts. You could always figure it out by changing it into exponential. The shortcuts just make things quicker. That's all, but you don't have to know them. Yes?
Basically, we see the same thing, cross them out.
I don't know if that is true. I wouldn't say yes to that. I don't know. That, I don't know. I don't know if that's true.
Yeah.
All right, let's go on to number 12. You guys do number 12. Do it on your whiteboards. guys could turn them over when you're ready. Good. Good. Oh, no. Why'd you write 3?
Why is it all 3?
No. Good. Oh, Meg, I didn't see yours. Good. Good, Aaron. Good, Meg. Good.
You can cancel out the second one?
What?
You can cancel out the log 3, 3.
You can't cancel them. Log 3 of 3 is 1 if you're using the shortcut. Okay, so how did most of you do this? Probably log base 3 of 27 divided by 3. Is that true? Okay, so then you had log base 3 of 9. Now, what did I say? Once you get it down to 1 log, you can always solve if you change it into exponential. So this is going to be 3 to the x is equal to 9. Well, 3 to what power gives us 9? 3 to the second power. Did anybody do this using shortcuts? No? Okay, then I won't clutter your brain. Yes.
So you can't cancel out the second one?
It doesn't cancel out, it's 1. Log base 3 of 3 is 1, not canceling out. It doesn't cancel out. That's what I was telling you. No, don't say it cancels out.
Okay. But like,
so this is 3 to what power gives us 3? 3 to the first power gives us 3. That's 1.
But then you use a 3 to divide that for 27.
No, you can't do that. If you're going to simplify it, so if you're choosing to do what you just did, you have to simplify both sides, which I don't think is a bad idea, but you have to know that once you take away this log and make this 1, you can't then divide anymore because there's no more log there. It's just 1.
Oh,
so then you'd have to solve this one. 3 to what power gives us 27? 3. So then it's 3 minus 1, which is 2.
So I wish this wasn't done. Yeah, that's pretty cool.
All right, 14. You guys try this one. All right, what should we have done here? I would have pulled out the log base 32 and then divided 56 by 7. And what's 56 divided by 7? 8. Janine, could you turn this into exponential for me?
32.
Perfect. I need to change these into the same base. Do we all agree this is 8 to the first? Right, I need to change them into the same base. I could change them both into a base of what? 2. Perfect. So this becomes 2 to the 5th raised to the x, and this becomes 2 to the 3rd. So now we have 2 to the 5x is equal to 2 to the 3rd. And then because they have the same base, what can I do with their exponents? Set them equal. Good. 5x is equal to 3, so x is equal to 3/5. What number was this? 14. 14. Okay, so this one's going to look intimidating, but don't be intimidated by it. What's wrong, Tice?
Can you check
Um,
I didn't even know 32 is 2. Just
I'll consider it. right, 16. 3 times log of 4 base 4/9 raised to the 4th root of 27/8.
Okay.
No.
Hold on, think about it.
We're not shutting down. We're going to go step by step. Can I pull this 3 and put it back as an exponent?
Yeah, so does that make it a normal square?
No. It doesn't make it normal. So this ends up becoming log base 4/9 raised to the 4th root. Well, how do I change the 4th root into an exponent? 27, nope, over 8 raised to what? 1/4.
Okay.
And then we're going to raise that to the, because I have to put that exponent of 3 back there, to the 3rd. All right, so all I did here was I took the 4th root and I wrote it as 1/4 exponent. Are we okay from how I went from the 4th root to 1/4? Okay, remember this 3 from front? Can't we put that back as an exponent on our argument? So that's what I did. So I had 27/8 raised to the 1/4 raised to the 3rd. Okay, let's keep going. So now, power to a power, what can we do? Multiply. So this is log to the base 4/9 raised to the, the argument is 27/8 raised to the 3/4 power. Okay, now we're going to go back into exponential. Back into exponential, I'm saying 4/9 raised to the x power is equal to 27/8 raised to the 3/4 power. Now this is the tricky part. Good job, Matt. That's exactly what we want to do. So right now, I can change 4 into a base of 2, right? And I can change 8 into a base of 2. I can change 9 into a base of 3, and can I change 27 into a base of 3? But are they matching up their positioning? No, so we want to flip it so their positioning matches where we have the same number in the same spot. How do I flip it? We not subtract, no. What'd you say, Charlie? Negative exponent, that's what we're going to do. So I'm going to have 4/9 raised to the x is equal to 8/27 raised to the negative 3/4. Now we're going to change into bases of 2 and 3. So we're going to have 2 to the 2 over 3 to the second raised to the x. I'm going so slow step by step here. Everybody okay with what I wrote there? Yeah? Okay, over here, I'm going to have 2 to the 3rd over 3 to the 3rd raised to the negative 3/4. Right, here's something from algebra that you have to remember. If I have the same exponent on the numerator and the denominator, I am allowed to pull out that exponent and just put it on the parenthesis. As long as it's the same exponent on the numerator and the denominator, I can pull out that exponent and put it on the parenthesis. So this is going to be 2/3 raised to the 2x power. I pulled out that exponent of 2. And over here, what do you think I'm going to write? 2/3 raised to the 3rd, but that's raised to the negative 3/4. Power to a power, what do I do? Multiply. Power to a power, we multiply. So this is 2/3 raised to the 2x equals 2/3 raised to the negative 9/4. All this just to get the same base. But now that I have the same base, can I set their exponents equal? Yes. So 2x equals negative 9 over 4. I can divide by 2, or I can multiply by a half. So x will equal negative 9 over 8. This would be like a bonus problem, in my opinion.
That was a little tough.
Right? There was a lot involved in here, but it's doable.
Not by me. Yeah, no.
Guys, I feel like I'm not happy with you.
Happy with us?
I'm not happy with you. There's too much complaining. What number was that?
It's more that I just
16?
don't have the confidence in myself to do that. Yeah.
Okay, so the next one,
I haven't done any adding.
all right, number 18. Oh, sure. How far back? Like there? You're welcome. All right, number 18. I want to see how you guys do with this one on your own.
Me too.
How many questions is this?
How many questions is what going to be? I don't know. I haven't made it yet.
Should I make it?
Should you make it?
Yeah.
Nah, you're all right.
Probably that easy.
This is the problem. Oh, I don't know the answer. Let me do it. 1 second.
So,
Hold on, give me 1 second. Okay, let me see, Aaron. Good. Good. Yes?
is multiplying?
Good. You got it right.
Okay.
We lost a sign somewhere. You're almost there.
Just negative.
Yes. Should we do it? All right, Matt, you're going to walk me through this. What did you do? Well, every time I have a radical, what do I want you to change it to? An exponent. I don't want to deal with radicals. So this is log base 8 of 1 over 16 raised to the what? 1/3. Now change it into exponential for me. So remember, it's log base answer equals exponent. So I want you to change this into exponential, no more log. So what's our base? 8. Do we know what it equals? So 8 to the x equals what?
1/16.
Raised to the
Third.
1/3. You have to, the key here is changing it into exponential. If you're able to change it to exponential, from there it shouldn't be too difficult. All right, now what are we going to do? I want to change 1 over 16 into just 16. What should I do to make that happen? Good. So this is going to be 16 raised to the negative 1/3. I want to change them both into the same base. Matt, what base should I change them into? 2. So this is 2 to the 3rd raised to the x, and 16 is 2 to the 4th raised to the negative 1/3. Power to a power, we multiply, so this is 2 to the 3x equals 2 to the negative 4/3. Can I now set their exponents equal? Yeah, so now it's 3x equals negative 4/3. What should I do now, Matt?
Do multiply 3 or divide 3?
We're going to divide 3, but dividing 3 is the same as multiplying by what fraction? 1/3. So that's what I'm going to do, multiply by 1/3. So that cancels. So x will equal negative 4 over 9. Do we all see how the key is getting it back into exponential? Once you're able to get it back into exponential, it shouldn't be bad. That was number 18?
Yeah.
All right, 20. So close. See how this 3 is in the front? Can I put that back as an exponent? So this is going to be e to the ln of, what's 2 to the 3rd power? 8. So this is e to the ln of 8. Yes? So what's the shortcut tell us? This is 8. You got it.
Wait, but why? I don't get how that.
Why is it like that? Okay, so this is e to the log base e of 8. Well, now you get it? Oh, okay. All right, we are done. So your homework, I'm going to post the homework right now. So we did all of the evens. You are going to do all of the odds.